The sunlit world we inhabit, the forests, the cities, the surface of the ocean, represents a tiny fraction of Earth's habitable space. Once you slip below the waves, the lake fades into crushing darkness, entering a realm that dominates our planet. This chart plots the tallest things we know against the Mariana Trench, the Burj Khalifa, and Mount Everest. If you drop Everest into the trench and stack the Burj Khalifa right on top, the combined height still fails to touch the ocean floor. 95% of the deep ocean remains unmapped. It is an environment where terrestrial physics are overridden, and life operates under an entirely different set of rules. On land, the maximum size of any living creature is dictated by a single force: gravity. A heavy skeletal structure can only support so much weight before it collapses under its own mass. The African elephant represents the maximum size a land-based mammal can reach without its bones splintering under the pressure of its own weight. Beneath the surface, those limits disappear. The blue whale grows to sizes that would be physically impossible on dry land. The ocean provides a biological loophole to gravity through buoyancy. Organisms develop specialized adaptations, like producing ammonia-rich fluids or filling internal bladders with air, to offset their biological mass against the density of the water. Because buoyancy neutralizes the downward pull of gravity, the ocean serves as an unrestricted engineering lab, allowing life to scale into giants. You might expect the freezing, pitch-black waters of the deep to stunt growth. However, these harsh conditions actually drive the largest physical variations of marine species. This process is known as polar gigantism. Near freezing ocean water holds significantly higher concentrations of dissolved oxygen than the warm water at the surface. This chart shows how that excess oxygen supercharges cellular metabolism. To absorb the high oxygen density, marine animals develop larger gills, which process more energy and fuel an explosion in muscle and body mass. This oxygen engine produces creatures of massive proportions. The colossal squid grows to the size of a car, with eyes as large as dinner plates. The freezing temperatures of the deep sea are not a hindrance to life. They are high-octane fuel for engineering monsters. While gravity is neutralized, the deep ocean replaces it with a different physical barrier: hydrostatic pressure. At the bottom of the oceanic trenches, the water exerts up to 16,000 pounds of force on every square inch. When humans attempt to combat this pressure, we rely on rigid, armored engineering, but even high-tech submersibles can fail instantly under this weight. Materials like carbon fiber and titanium expand and compress differently. This mismatch causes microscopic stress fractures, leading to a violent, instantaneous implosion. Nature takes the opposite approach. The snailfish survives these depths without rigid bones. It uses a gelatinous body and produces cellular chemicals called piezolates, which prevent its cells from being crushed by the external weight. We try to survive the deep by building rigid armor to keep the environment out. Nature survives by adapting softly, allowing the most violent forces on the planet to flow right through its biology. Because deep-sea biology is so finely tuned to the planet's internal chemistry, their presence at the surface frequently precedes tectonic activity. The oarfish is a deep-sea resident equipped with an acute sensitivity to subtle vibrations and magnetic changes within the Earth's crust, the earliest signals of a shifting planet. Multiple sightings have aligned with seismic disasters. In 2011, oarfish washed ashore in Japan shortly before a magnitude 9.0 earthquake. Similar sightings were recorded days before major tremors in California and Mexico in 2025. These creatures are unsettling because they possess a sensory mastery of planetary forces. They detect tectonic shifts directly, while humans rely on specialized instruments to translate those same signals. Human fear of the deep sea is rooted in an evolutionary response to the unknown. The brain interprets a lack of data, the absolute blackness of the water, as a direct threat. With 95% of the ocean floor still unmapped, biological engineering has been running its course in the dark for millions of years. This timeline has continued entirely uninterrupted by human activity. The deep sea is a specialized, occupied environment, where life has followed a trajectory separate from the surface world for eons. We do not avoid the deepest parts of our planet because they are empty. We stay away because we are uninvited.